Hey Algebra 2, today I'm going to teach you how to simplify radicals. So we're going to have addition and subtraction that are happening today. And so if you look over here, I have a times the nth root of x plus b times the nth root of x. And so as long as those indexes right there are the same, you could rewrite this as the quantity a plus b times the nth root of x. So in order to have like radicals, you have to meet two criteria. Number one, you have to have the same index, and you have to have the same radicand. So recall that the radicand is the numbers under the radical. So if you glance down here at number one, these are examples of like radicals. They're both an index of 2, and there's a 5x under each of them. So I will be able to add these two together. And so the a and the b, that's just that 3 and that 2. And there's subtraction happening right now. So I would write this as 3 minus 2, and then radical 5x. And then we just add the numbers in here, and we would have 1 radical 5x. Or sometimes we get lazy and we don't put the number in front of there, or you would just write it as radical 5x. So both of these are good answers. And then here we have the same thing, but with subtraction. You would just have a minus b, and then the nth root of x. So I would like for you to recall like terms. Like terms would be like 3x plus 2x. As long as you have the same variable right there, you just add the numbers out in front. So 3 and 2 equals 5x. Same thing with radicals. If I have 3 radical x plus 2 radical x, all you got to do is add those numbers out in front, and you get 5 radical x. So here on number 7, I have the same index. However, I have a radical 7 and a radical 5. So I have different numbers under the radical symbol. So therefore, I cannot simplify this any further, and I would just write fully simplified. That one is all done, ready to move on to the next one. Number 3. That one has an index of 3, and that one has an index of 5. I don't care anymore that the numbers under the radical are the same. I have a different index, so therefore that is my stopper. And this one is also fully simplified. Do I have the same index? Yes. Do I have the same number-letter combination under the radical sign? Yes. So then I just go 17 minus 15. 4th root of 3x squared, that would give me 2 4th root of radical 3x squared. So I look for, as long as everything about the radicals match, I'm good to go. So number 5 and number 6 is the heart of what we're doing today. Just because you see different numbers under the radical sign doesn't mean that you get a stop. What you do is, number 1, you have to look and you have to see, are all these radicals simplified? So you have to simplify all radicals first. All right, so we did this the other day. I have the square root of 12. So when I have square roots, recall my perfect squares are 4, 9, 16, 25, etc., etc., etc. So I'm going to break 12 down into the product of 4 times 3. Because 4 is a perfect square, and this first one simplifies as 2 radical 3. Oh, hey, I'm making progress. I have another radical 3 right there. I'll be able to do something in a minute. All right, so we're going to keep going with this one. 75. Well, the 25 jumps out at me, that 25 is a factor of 75, and that would be 25 times 3. The square root of 25 is 5, radical 3. And I need to be careful and watch my signs. Bring down your plus in between those. And then I have minus radical 3 I can't do anything with. All right, so I have all the same radical. So now I can just add the numbers out in front. If there's no number out in front, you need to know that there's always an implied 1 there. So I'm taking 2 plus 5 minus 1. And I'm going to tag on my radical 3. 7 minus 1 is 6 radical 3. That's how you go through and simplify them. Number 6 is the same thing, but you got to be careful because now we are talking about cube roots. So I'm going to list out my perfect cubes. They are 8, 27, 64, 125. So I took it all the way out to 125, mainly because I saw a big number right here. So 125 times 2 is 250. So I'm going to break this one down into 125 times 2. The cube root of 125 is 5. So this first one simplifies 5 cube root of 2. Let's see, 54. Let's see, 8, I don't think so. 27, I don't know. So I went in my calculator and I did 54 divided by 27, and I got 2. So I'm going to rewrite that as the product of 27 times 2. Now I'm going to take the cube root of 27, which is 3. So that becomes 3 cube root of 2. 16, I know that that's 8 times 2. So when I break that one down, that's 8 times 2. The cube root of 8 is 2. So now I have all the same numbers under the radical. Now I'm just going to add their numbers out in front. 5 plus 3 minus 2. 8 minus 2 is 6. Backside. All right, so we have 2 terms times 2 terms. So we are going to have to FOIL these. Maybe you guys called it distribute. So number 1, we are going to distribute. And then number 2, I call it CLT, which stands for combine like terms. So the first thing I'm taking is 4 times 5. And then I'm going to take 4 times 4 radical 2. Its job is done. Now I'm going to move on to 2 radical 2. And I'm going to take 2 radical 2 times 5. And then I'm taking 2 radical 2 times 4 radical 2. As you get better at this, you might not have to write out every single term, but this is how I'm going to start my lesson. 4 times 5 is just simply 20. So right here, what you need to know is that these 4s are called integers. So numbers outside of the radical, you're allowed to multiply together, and then numbers under the radical, you're allowed to multiply together. So 4 times 4 radical 2 is 16 radical 2. On the next one, that 2 and that 5, those are the integers. Those are the numbers not under a radical. So 2 times 5 is 10. Tag on your radical 2. Right here, the 4 and the 2 are not under the radical, so I can multiply them together. I get 8. And then I'm going to multiply these two 2's together, and that's going to stay under the radical. So 2 times 2 is 4. All right, so what would I do here? I'm going to do a couple of things. I'm going to keep my 20. There's not much I can do with it yet. When I look right here, I see that I can combine like terms because they each have a radical 2. So 16 and 10 adds up to 26 radical 2. This says 8 times the square root of 4. Well, I know what the square root of 4 is. So right here, this, I'm going to have to simplify. The square root of 4 is 2. And then I know that 8 times 2 is 16. And so then when I look here, I have these 3 terms. Now I have 2 plain old numbers that I can go ahead and combine. So 20 and 16 is 36 plus 26 radical 2. So the constants, the plain old numbers, they didn't have any radicals. They can't do anything with them. So they're one number, and then the radical is another number together. And let's do another one. All right, so I'm going to take the 5 and distribute. So I have 5 times 5. I'm taking 5 times negative radical 7. Sorry. That gets me a negative 5 radical 7. And now when I distribute positive radical 7 times 5, it would be customary to put your coefficient, your regular number term, before your radical term. So right here, I'm just going to switch the order, and that's 5 radical 7. Now I have radical 7 times negative radical 7. So a positive times a negative is definitely a negative. And 7 times 7 is 49. That needs to be under a radical symbol. So right here, I'm going to combine like terms. I have a positive 5 radical 7 and a negative 5 radical 7. So once again, what we did is we took negative 5 plus 5 radical 7. Negative 5 plus 5 equals 0, and anything times 0 is 0. So when I combine like terms, these two zero each other out. So 5 times 5 is 25. I have to deal with u. And then I know that 49 is a perfect square. The square root of 49 is 7. And then 25 minus 7 equals 18. All right, let's teach you a little shortcut. Let's talk about radicals for a minute. I just took the square root of 7 times the square root of 7. Anytime you take a radical times itself, it equals that number. So radical 7 times radical 7 equals 7. Why is that? Well, we said the other day that if you could multiply, they would go under the radical sign together. I have an implied index of 2. Once upon a time, we were grouping them, and if you have a pair, one comes out and the other one, hey, that's a 7, my bad. Sorry. So you just get a regular 7. So if you have like the square root of 5 times the square root of 5, that's just 5. If you learn this shortcut, that's great. If this does not agree with you, then just multiply the numbers under the radical and then take the square root of the number. You will get the same answer every time. The last two, we have some squares. So anytime you have a term being squared, you should always rewrite it. So once I rewrite it, now I'm going to do exactly what I did on the prior two problems. I'm going to multiply FOIL. So 3 times 3 is 9. 3 times negative 2 radical 5. So the 3 and the 2 are outside the radicals, so that is negative 6 radical 5. Now I'm going to move on. I'm going to distribute negative 2 radical 5. Negative 2 radical 5 times 3 is negative 6 radical 5. And then when I take negative 2 radical 5 times negative 2 radical 5, the negative times negative goes positive. You multiply the numbers out in front. 2 times 2 is 4. And the numbers under the radical, radical 5 times radical 5 equals radical 25. I have like terms right there. Negative 6 minus 6 adds up to negative 12 minus 5. So you got to know that this one's different than the other one because these are the same signs. And so when they're the same sign, you got to add them and keep the negative. And then here, the square root of 25 is 5. And then 4 times 5 is 20. So now I recognize that I have two plain old numbers right there. And 9 and 20 is 29 minus 12 radical 5. So as a normal customary formatting, let's always put the plain old number first, and let's put the radical second. So when you have a plain old number and then a radical term, let's put the plain old number first and the radical second. And I will have the others done for notes. Thank you.